Alright everybody, welcome to our next topic, which is variables, concepts, and measures, chapter 3. So this is meant to be sort of an overview of terminology we'll be using, and hopefully a review of some terminology that you have heard in your statistics course. We're going to learn some of the important differentiations between types of data that will ultimately indicate what types of tests we can run on our research projects. So let's just go ahead and get started. Alright, first off, what is a variable? So the word variable should sound a little bit familiar. The root word here being the same for variance. It's Latin variabilis, which means to change, changeable. So it's anything that can vary. That can also be measured. The simplest form of variance we have is a characteristic or quality that has two different values or categories. Take a yes or no question, for example. Your response can vary, but there are only two options. Otherwise, if we have something more consistent or constant, we would call it a controlled variable or a constant variable. As I mentioned, variables are rooted in statistics. Variable is a statistics term, and variables are quite useful because they help us to categorize and organize our data. In fact, we like to put our data into as small of boxes as we can, and we do that by organizing them by different types of data. So we'll be taking a look at the four major types of data here. Okay, concepts versus variables. So before we do, we'll talk about another important type of concept here, being a concept. What is a concept? So concepts are sort of large, overarching phenomena or ideas that encompass our variables of interest. So an umbrella with lots of things underneath composing it. Let's take, for example, something like life satisfaction. Say you want to measure somebody's life satisfaction. Well, we could treat that as a variable, have somebody respond to a question, maybe how would you rate your life satisfaction on a scale of 0 to 10? But if we think about it in smaller parts, we might think of other small variables that contribute to life satisfaction. Maybe our social satisfaction, our career satisfaction, our romantic satisfaction. You know, are you happy with your spouse's cooking? You know, whatever. The list goes on. Maybe satisfaction with our family relationships. So this is actually an idea that comes from multivariate statistics, meaning that we have latent variables or hidden variables. So our concept or our big idea would be called something like a latent variable, which really means a combination of many variables, a variable with other things hidden inside of it. This leads to this kind of criticizing of the use of variables in science, especially psychology, because we're often only looking at one variable within the scope of a much larger concept. So I have here that variables are what we create to try and measure concepts. So no one variable will ever get at an entire concept of interest. But remember, we like to have our variables in neat and tidy boxes so we can organize them and run analysis with them separately to help answer our questions. Here's a reminder of some very important variables. We'll talk about these and then we'll talk about our four major types of data. But this is meant to be a reminder and sort of a different approach to the independent and dependent variable. Previously, I had mentioned that I like to think of these very simply as predictors and outcomes. Predicting variables and outcome variables. I think that's the easiest way to look at it. So if we look at this graph over here, okay, we have an amount of fertilizer and plant growth. The predictor would be the amount of fertilizer you give. The outcome would be the height of the plant. So in most research situations, we'll have just that, a clear predictor and a clear outcome. But a definition of the independent variable that you've maybe heard before, so I do like to touch on it, is that the independent variable is manipulated by the researcher. So if we take this example of the fertilizer for a plant, of course we could manipulate that. We can change that. But we'll talk about some variables later that aren't so easy to manipulate. So that's why I like to make say be careful when we approach the word manipulated, because it's not always as clear cut as this. But nonetheless, it is a way that the independent variable is talked about a lot. So I want to make sure that we do, touch on that a little bit. All right, four major types of data. So now we're moving into four major types of variables or major types of data. We have nominal variables, we have ordinal variables, we have interval variables, and we have ratio variables. So we're going to talk about each of them in order, and we'll talk about how they sort of play on each other or where they differ from each other. So first we have nominal variables, okay? It comes from the Latin word nomine, meaning name. So it's a word we can use to describe nominal variables. Qualitative, okay, is a word we can use to describe nominal variables, meaning it describes the quality of something as opposed to the quantity of something. And we'll talk about quantitative variables next, okay? Or categorical is another word. Nominal is synonymous with categorical, meaning that we have categories that we place these data into. We're just simply naming things, okay? So back to our idea where the simplest variables have 2 points that vary. We can have categories that are this simple. You fall into one of two categories. This would be a binary variable, or a dichotomous variable, or a binomial variable, because of course we have to have multiple words for the same thing. We can't keep it simple. But again, think of this as maybe a true or false question on an exam. That would be nominal data. You fall into one category or the other. We don't necessarily assign a point value to it, although we could, but there's no inherent value to true or false. Those are simply categories. We can have more than two categories. We can have lots of categories. We can take something like ethnicity, where we have a long list, and you choose which category or categories you belong to off of that list. So where this gets a little tricky is people like to add, and including us, we're going to code data in the future. People like to add numeric identifiers to nominal data. Take something like a zip code. I have a local zip code, right? It doesn't mean that another zip code of a greater value means that it's bigger, that it's a greater quantitative value. It just means a difference in quality, or in this case, a different geographic location. So we often slap numbers onto categories for our own organization, but it doesn't mean that one, in this case the zip code, the area, has a greater value than the other. Okay, so that's nominal variables. They're just we're just naming things. The key word here is categories, okay? Names. These are categories, and yeah, we'll just sort of leave it at that. Okay, so next up we have ordinal variables. So ordinal variables are a little bit what they sound like. They move in a ranked order. Ordinal order. So ranked order is our key word here. So we add a value to each thing being measured that indicates a relative order on some characteristic. So an example that I like to use is rating peppers from the most spicy to the least spicy. We come up with some different type of peppers. Maybe we can come up with some non-spicy peppers, things like bell peppers, pepperoncinis, jalapenos, although I find jalapenos spicy. We can come up with some very, very spicy peppers like ghost peppers, scotch bonnets, habaneros. So we have a general rank order here. We could rank those 6 peppers from the most spicy to the least spicy. And then we have some sort of quantitative information. Quantitative, the amount. That one is greater than the other. But what we miss out on with ordinal data is equal intervals between our measurements. So what does that mean? That means that the relative spiciness between, say, a bell pepper and a jalapeno is not equal to the relative difference in spice as there is between a scotch bonnet and a ghost pepper, even if they're one away from each other on our ranked order list. Okay, it's not the same distance. So this is the sort of pitfall here, but it's a great way to organize data into some type of quantitative or ranked order list. It's just not super accurate. I also include women's dress sizes here because they're a little bit of an enigma, a mystery, right? They're ordered 0, 2, 4, 6, 8, and beyond in even numbers, but the difference in size between, say, a 0 and a 2 is not necessarily the same difference in size between a 6 and an 8. Although we can say with certainty that an 8 is bigger than a 6 and that a 2 is bigger than a 0, okay? So I'll give maybe a more well-known example of this. So we've maybe seen something like this before. There are measurements of pain measurement scales. This general scale is used worldwide, really, in order to get an indication of pain. So pain, if we try and understand it on a psychological level, is very difficult to measure. How pain works is that we have receptors or neurons in our body that send messages to our brain to say that something about our body has been damaged, and that's how pain is relayed in the body. But there's no way for us to prick someone's finger, take their temperature, and know how much pain they're in. So we resort to a rank order scale, ranking from no pain at all to the worst possible pain. And this is usually the general idea, but there's been much debate about the best way to do this, okay? Because it's imprecise. Do we try to get people to select their pain level based on a verbal scale? Like you see down here below, or a visual scale, like we see up above. Should we use colors, or emojis to get the idea across? So I'll point out a few things here of why this is difficult. Pain, again, is a broad field in psychology, and one of the biggest questions is how to measure pain accurately. So if you have any big ideas on this, you might just have a career ahead of you, right? But if we look at the top one, let's think about a few reasons why this might be problematic. Scales like this are usually directed towards children or maybe people that are not native to the language in which they're being asked to rate their pain, because the images can help to advise where they want to put themselves on the scale. But some criticism of a scale like this, maybe somebody doesn't cry when they're in pain. So they might be in the worst possible pain or the worst pain of their life, but they're not going to select a 10. Maybe their face looks something more like a 4 on the scale. So let's take a look at a couple more here. These ones are more for laughs, okay? But this top one here, it's on the same type of scale from no pain to worst possible pain from 0 to 10, but there's a human face indicating pain. But if we take a look at this, these aren't necessarily so great either. Maybe we don't make exactly these expressions when we're in pain, okay? So nonetheless, it's an idea to get a better measure of pain. And then below we have a cute one directed towards kids. Finn the human right here expressing different levels of pain. They're using a few different methods to do so, from the facial expressions to the exact skin tone color of his face. So this sort of bridges the gap between ordinal data and what we're going to talk about next, which is interval data. So we go from categories to intervals, okay? So remember, ordinal data moves in a rank order, and interval variables are interval data. There's equal intervals or equal increments between 2 points on the scale. Remember that this is something that we do not have with ordinal data. So if we have a ranked order list of characteristics, the differences between the distances between any two sets of data on that list are not guaranteed to be an equal distance apart. So interval variables, they are on a number line with equal distances in between them. And then the first bit that I have here is about the difference between interval and ratio scales. So we're going to talk about ratio scales next, so just sort of keep this in your mind, is that interval and ratio variables are almost identical in function. And for us, in terms of our class, we're going to treat them entirely the same. Statistics treats them entirely the same, but we're here to just talk about the conceptual difference between the two, okay? And the difference is that interval variables do not have a clear 0 or a true 0 point. So what does that mean? That means that we don't have a 0. That means the absence of whatever it is that we're measuring. There is no absence, okay? There's no 0. It's not possible. So I have a couple of examples here. Interval is a little strange. We don't have tons of examples of interval data, but here's two. We have temperature, okay? So we can measure temperature in a few ways: Fahrenheit, Celsius, Kelvin. And there are zeros on each of those scales, but the 0 never means an absence of temperature. There's still temperature outside, something measurable. So 0 is more of a label for a particular level of temperature, but it's not a true 0 that's universal across the measurements, right? Sell by dates is another example, or really just dates in general. Here we might get a little controversial, but there's no universally agreed upon 0 day. We don't really have an agreement on a time or a date which we could point to as 0. Some people still eat things after the sell by dates. So we can think of other variables that might have the same sort of difficulty, where we can't place a true 0 on the scale of measurement, okay? Ratio variables, very similar, but just differing on that 0. So ratio variables, remember, are going to be just about the same. However, there has to be a 0 point on the scale, which indicates 0 measurement of whatever it is that we're measuring. So let's take a couple of examples. Maybe weight. If you're trying to weigh something on a scale, if the scale is telling you 0 weight, that means there's an absence of weight on the scale. 0 is actually meaningful. A test score, you have the same thing. You can get a 0 on a test. That's not good, but you can. I have students who occasionally do that. It means an absence of a score or an absence of credit on that particular test. And then income, also not good, okay? But can you have a 0 income? Yes, you can. It's tragic, but you can. Can you have negative income? You can. That's even more tragic. That's called debt. But you can have positive income as well, and you can have 0, okay? So what's important here is that the 0 means something. The 0 means an absence of income. And we also have equal intervals between our measurements. So you can basically be $20,000 in the green or $20,000 in the red. It's the same amount of money. No matter how you slice it, it's the same amount of money. So that's where our equal intervals come in versus the ordinal, okay? So again, this is just meant to be sort of an overview of these ideas, and we're going to start putting them into practice when we're running our different statistical exercises in the class. This is important because it dictates what type of analysis we can do. We can't get a mean of categorical data, but we can get a mean or an average of this type of data. So it dictates much of what we do in regards to testing. So those are our four major distinctions or four major types of data, but now we're going to talk about some other types of variables. All right, so here's a data types flowchart. I think this can be helpful. This is just sort of a flowchart of the ideas we just talked about. Nominal variables are kind of off on their own, okay, because they're categories, and the rest are considered quantitative. So hopefully this can sort of help to guide you. I think it summarizes it pretty well here. Okay, so take a look at that on your own time. So now we're on to subject variables. This is a sort of overarching type of variable. So these are variables that cannot be manipulated by the researcher. So remember, this word manipulate comes from the Latin word manus, for hand. It's often used for the independent variable, although that can be a little confusing, and this is why. There are variables that we can't manipulate for our study. We can't have somebody come in and we can't manipulate their gender, their ethnicity, their sex, their age. Well, I guess in some ways you can nowadays, but generally speaking, we can't manipulate those things. Those are things that are inherent about the person. They're born with it. What they walk into the room with, we can't change. Say their level of education. We can't change it for the sake of our study. But oftentimes we want to use these types of variables as our predicting variables. Maybe somebody's age predicts their life satisfaction. Maybe someone's academic background predicts their career success. So it's not to say that we can't use these as predicting variables, it's just that we can't manipulate them. So I say, can we make it our independent variable? And yes, kind of. We can, as long as we accept that we can't manipulate that variable, at least during this study. And we talked about causality before. We need to do an experiment to indicate a cause. And to do an experiment, we have to manipulate our independent variable. So again, this is just sort of the verbiage of research. If you want to do a study on one of these variables as your independent variable, you're not going to be able to manipulate an experiment in the same way you would if you were using more easily manipulated variables. But they're still independent variables. I know, confusing. And then lastly here, we have operational definition. So no matter what type of variable you're working with, you'll need to define how you are measuring that variable. This might seem sort of straightforward, but we can think of a few examples where it's maybe not. Let's think about happiness. Happiness seems like an easy enough variable to investigate, but how do we define happiness? Happiness in your day-to-day life, general happiness, happiness with your career, happiness with your education, happiness with your family. We can kind of dig into all the different variables that would contribute to happiness. But regardless, if you want to measure something in your study, you need to define how you will be measuring that variable so other researchers can come along and see if they agree on how we're defining that variable. Okay? Because they might define happiness differently the way you do. So in this image here, it talks about a few different ways that we can measure intelligence, and we can kind of look at these and decide whether we think they're adequate. So we have here measuring intelligence by using the verbal SAT. We have intelligence by the speed of someone repairing an engine, calling this a behavioral definition of intelligence. And then we have just a ridiculous definition on the bottom, right? So this might seem a little crazy, but intelligence tests, if you actually want to give a standardized intelligence test, can take upwards of 4, 6, maybe 8 hours. So maybe you want to measure intelligence in a different way. So you operationally define it as one of these things. Well, another researcher might come along and say, hey, that's not what intelligence is to me. Or that's not how I want to measure intelligence. You know, the number of hairs on your left thumb, that's stupid. So another researcher would probably criticize you for that. So the point being, we'll be doing operational definitions of the variables that we choose to use in the papers you're writing for this class. That's part of writing a research report, is explaining your variables, how you're defining them in terms of their measurement. Okay? So that's all for variables, concepts, and measures. I hope you understood that. If not, send me a question, and I will see you guys all over on our next video. Bye!